So you've probably studied logarithms before, and you've discussed that they have bases. So the bases, technically, there's a lot of ways to talk about what the base means, but one of the ways is that they represent the shape of the logarithm curve. So if you have a log of any base, that log of 1 is still 0, and it still has the same domain and range. So it comes up from negative infinity and goes to positive infinity. But that base changes, it's a scale factor. So it still goes through that point, but it might bend up or bend down, but still has that same overall shape. And you could do this by taking this into, a graphing calculator or whatnot, and plotting the natural log of x versus the log base 2 of x or something like that. And you'll notice they have very similar shapes. But they all have this relationship with their base, is that the log with a particular base, if you evaluate it at the base, is equal to 1. So what does that mean? That means that log base 4 of 4 is equal to 1. Log base 10 of 10 is equal to 1. Log base 100,000 of 100,000 is 1, and so on and so on. Now, it's important to note that you can't have a base 1 for a log, because otherwise everything would go wild, because log base 1 of 1 should be 0, but so log base 1 is it's not valid to do, just so you're aware. But the natural logarithm, you might wonder, what's the base of that? Well, it's this number e. So you might have dealt with e before, maybe in like continuously compounded interest, for instance, or what they call exponential growth models, anything like that. Those use the number e for the base. So we write this as a shorthand. We write ln of x to really be a shorthand for log base e of x. So this is really, again, this is just a natural log ln. Now, but that means that it has this relationship, that the natural log of e is equal to 1, because that's log base e of e. And even more generally, this is the more helpful piece, is that log base e to the n is equal to n. And that follows directly from that property that says we can bring the power down front, so you have n times natural log of e, which we know is 1. So it's n times 1, which is 1. So anyway, if we were to build a table of values, you'd have this 1 over e squared, so that's like e to the negative 2. The natural log of e to the negative 2 is negative 2. The natural log of e to the negative 1 is negative 1. Well, e to the 0 is just 1, and the natural log of 1 is always 0. The natural log of e is 1. The natural log of e squared is 2. And technically speaking, e is defined as this. So what's interesting about the natural log is it's defined in terms of an integral, and e is actually defined in terms of a limit. So both of those pretty much need calculus to be defined. So that's kind of an interesting piece there, that's how that can be defined. But anyway, that's the reason why we point this out, is that since this is kind of it's not just a simple compact, it's not just 4, it's not just 3, right? It's some special number. Then its base is going to have sort of some consequences that really, and this is true for a lot of logs, but specifically the natural log of simple numbers, like whole numbers, outside of 1, the natural log for any natural number is going to be some sort of decimal expansion irrational. It's not going to be nice. You're going to have to plug it into a calculator. Like the natural log of 2 is kind of like 0.693, and then it's going to keep on going. And 32 is 3.466. It's just going to keep going. And the natural log of 0.1, now this is going to be negative, because remember, the natural log, or the log generally, of any number less than 1 is always negative. So you end up with negative 2.303. And I didn't write this, but there's also the fact that the natural log of 10 will be the same thing without a negative. And you might ask, well, why is that true? Well, it's true because if I had the natural log of 0.1, that's the natural log of 1/10, which is the natural log of 10 to the negative 1
which is -1 times natural log of 10.
So what you find is that has that relationship. So what's kind of neat about that is,
Generally speaking, natural log of, and this is true for any log, but
you can do that, which again follows directly from the original properties, because that's natural log of 1 minus natural log of x, and natural log of 1 is 0. So anyway, this is a good thing to keep in your pocket. It's very, very useful for what you may be trying to do. And generally speaking, you're going to need a calculator when you're dealing with logs.